Now we want to look at some example of vector space. The first example, which is use a tradition of two-dimensional vectors, the arrows to represent those. So just we use the usual additions, use a parallelogram additions, and the scalar multiplications. So if you look at that, so if you have an arrow, which is v, 3v, which is simply 3 times the same directions. Negative v simply is reverse the directions. And this is in 3 dimensions. This satisfies all the axioms. You can go verify that. Following the adding and subtracting associated property, they all follow that. Another example we have is a 2 by 2 matrices collections, all of them. And this itself form a vector space. You have multiplication principle followed by the matrix multiplications and the addition principle. Another thing is the set of all polynomials of degree at most n is greater than or equal to 0 is the collection of all such elements, meaning all the polynomials with at most n greater than or equal to 0, meaning you have a set number of the degree, and the collection of those satisfy all the 10 elements there, and the multiplications and additional principles simply follow the regular traditional multiplication and addition of a polynomial. So these are the, in traditional sense of sets of, it's called vector space. Remember, vector space is not just a collection of elements. Vector space is a collection of elements plus and two operator additions and multiplications.